Okay, let's grade the Chapter 7 test. Number 1, we are to define hygroscopic, and that means readily absorbing moisture even from the atmosphere. The limiting reactant, 1B, is the reactant that you run out of first, and it limits the amount of product that can actually be made. Number 2, if I have 6.02 times 10 to the 23rd atoms of silicone, how many grams of silicone do I have? Well, you know that there's 1 mole in 6.02 times 10 to the 23rd, so you're to look at your periodic chart, and it gives you that there are 28.09 grams of silicone for every 1 mole. So that's the answer, 28.09 grams. Number 3, how many moles are found in 100 grams of copper fluoride? So we have 100 grams, 100 gram sample of copper fluoride. And our question was, how many moles is in that? So we're going to go times line, grams of copper fluoride, and we want to know the moles of copper fluoride. So in every 1 mole, you go and you add up 1 copper plus 2 times the iron, and that gives you 101.55 grams of that. In case you needed to see that, the copper is 63.55 grams. I'm going to skip the AMUs and go right to the grams. And 2 times the iron, which is, oh, it's not iron. So sorry. I said iron before, but it's actually fluorine, and it's fluoride in this case. So 2 times the fluoride, which would be 19 grams. And so that's going to give us, when we add it all together, the 101.55. Okay, now, this is going to cancel. We have 5 significant figures here, but we have 4 significant figures there, so our answer has to be in 4 significant figures. And so it's going to be 0.9847 moles of copper fluoride. Sorry, I said iron before. Copper fluoride. There you go. Okay. Oh, if your significant figures are off, let's figure out what these are worth. Hang on. Got to take off if your significant figures are off. Okay, every one of his points is actually worth, is actually worth 3 points. And remember to add up what you miss and then subtract that number from 100 to get your score. And so this problem is worth 3 points. So if you didn't do the right number of significant figures, you're going to take off one of those 3 points. And so the significant figures are very important. You've got to watch them. Then we get to number 4. And number 4 says a chemical reaction produces 11.8 moles of tin. How many grams of tin are made? So we have 11.8 moles of tin. And we want to know how many grams that is, so we're going to go moles of tin to grams of tin. We know in 1 mole, and we look on our periodic chart, and we see that tin is 118.71. We start with 3 significant figures, so our answer has to be in 3 significant figures. And it comes out to be 140. And we want us to show 140 in 3 significant figures. You could either go like that and put your decimal place there showing that this is 3 significant figures, or you could have written it this way. But it had to be one of those 2 ways showing the 3 significant figures for 140. And you had to write grams of tin. If you don't have the right number of significant figures, you lose a point. And if you don't have grams of tin, you lose a point. And the whole problem's only with 3 points. So you want to make very sure that you're doing those each time. If you didn't do that throughout the test, you want to stop this right now, go make sure that you did that, and then come back and finish grading the test. I don't want you to keep missing all these points because that part's too easy. Number 5, hydrated cobalt chloride is deep purple in color. After being heated for a long time, it turns into an anhydrous form, which is sky blue. Is this a chemical or a physical change? This is a physical change. It is not a chemical change. We had a question just like that on the review problems, didn't we? Number 6, hydrated sodium sulfate has a chemical formula of that. Okay, A, what is the chemical formula of the anhydrous form of the same compound? Well, the anhydrous form would just be taking off the water, so it would just be the sodium sulfate. How many water molecules are there for every one sodium sulfate? This is a 1 to 10. This is the anhydrous form. Now I'm going to write the hydrated form up here. And you see here that there's 1 of these to every 10 of these, so the answer for B would be 10 water molecules for every 1 sodium sulfate. C, a chemist starts out with 15 grams of anhydrous, so we're going to start out with 15 grams with 3 significant figures of anhydrous sodium sulfate. If she hydrates the compound completely, how many grams of water will be added to the sample? Okay, so first we're going to have to figure out how many moles this is, because I'm going to go ahead and write it back up here. We know that in its hydrated form, this is attached to 10 waters. It's a 1 to 10 relationship. So let's figure out how many moles this is. So we're going to go like this, and we put whatever's here down here. And we've got moles up here because we need to know how many moles that is. And when you add this up, 2 times what sodium weighs, 1 sulfur, 4 times 16, that's going to give you 142.04 to every 1 mole of this. And so 3 significant figures, you're going to have 0.106 moles of the sodium sulfate. Now once you have that, we can figure out how much water that is, because we know that there's 10 times that many moles of water. So when we multiply that by 10, it gives us 10.6 moles of water. I moved my decimal place over, still have my 3 significant figures. Now once I have, you see what I did. So I figured out how many moles this is, and I know it's a 1 to 10 relationship, so I multiplied it by 10. And now I can take that number of moles of water, and I can find the grams of water very easily. And 3 significant figures in my answer, that's going to give me 19.1 grams of water. And so your answer would be 19.1 grams of water. And this is why. Now he's got this worked out so that, let me get you the grading on this. There's 3 points for this step, so getting to the moles of this, 3 points for multiplying this by 10 and getting to here, and then 3 points for getting this step. So there were 3 points, then when you multiply this by 10, that's 3 points, and then when you do this work, that's 3 points. If you missed on the significant figures, take off a point for each place that you missed on the significant figures, please. So that makes this problem was worth 9 points, the way he's got it calculated. Okay, let's go to number 7. Number 7. What is the mass of 169 moles of carbon tetrafluoride? So we have 169 moles of carbon tetrafluoride. We want to know its mass. We're going to go like this to the grams of this. We know in 1 mole, and then we go to our chart, and we know that it's 4 times 19 plus 12, and that's going to give you your gram molecular weight of carbon tetrachloride, which is 88.01. And so that is going to give us, in 3 significant figures, 14,900 grams. So that's a lot, isn't it? And I just want to see something. Okay, what came out of the calculator, that's kind of what I was worried about, is this. But you have 3 significant figures. So you have to take this to 3 significant figures. And you look at this one to see if this rolls up or not. Well, 7 is definitely going to roll this up. So this is going to be your answer. You could have written that answer as 1.49 times 10 to the 4th grams of carbon tetrachloride had you chosen to. So that was what came out of the calculator, but because of the 3 significant figures, you're going to have one of these 2 answers for it to be right. Okay? All right, let's go to number 8. Number 8, how many molecules are in 671 grams of CO2? 671 grams of CO2, and I want to know how many molecules that is. Okay, so we're going to go to moles because I know how many molecules there are in a mole. So I can go like this and go to the moles of CO2. In every 1 mole of CO2, there's 12 plus 32, which is going to be 44.01. And so that'll cancel, and that's going to leave us in 3 significant figures, 1, 2, 3. It's going to leave us 15.2 moles of CO2. Now we have the moles. It's easy to find the molecules because you just go like this. Moles of CO2, molecules, and a mole of CO2. There are 6.023 times 10 to the 23rd molecules in every 1 mole. So now that'll cancel. And we have 3 significant figures both places. And so that's going to end up giving us 9.15 times 10 to the 24th molecules of CO2. So you took your mass, you went to the moles, and then from the moles you were able to convert it into the molecules so that you could say how many individual molecules there were in that mass. Once again, if your significant figures were off, then take off a point. Okay, let's go on to the next one. Number 9, fill in the blank for the following reaction. Blank moles of aluminum react with blank moles of bromide to produce 2 moles of aluminum bromide. So you should have put 2 in the first blank for the moles of aluminum, react with 3 moles of bromide. So 2 is the first blank and 3 was the second blank. Number 10. A chemist makes aluminum sulfide according to the following chemical equation. That he runs the reaction and then finds that in the end lots of aluminum sulfide is made and the other chemical, that in the end lots of aluminum sulfide is made and the other chemical present is the sulfur, S8. What is the limiting reactant? Well, if you have leftovers of the sulfur, then the other reactant, which is the aluminum, had to be the limiting reactant, and therefore the answer would be the aluminum. Okay, number 11. The combustion of propane occurs according to this equation. It's very nice of him to balance that for you. If 901 moles of propane are burned in excess oxygen, how many moles of carbon dioxide are formed? I guess I have to put it down. Okay, so we go. C3H8. And we want to know how much CO2. So I'm going to, let's do plus, cut to the chase. And we want to know CO2 gas. Okay, we are starting with 901 moles of this. And we want to know how many moles of this are formed. And so we go 901 moles, C3H8, 8 times line, whatever's here, always goes down here. And you can go directly across this bridge or tunnel, however you want to look at it. I like bridge better, but moles are in tunnels. Anyway, so that's 3, that's a 1. And so that is going to give us in 3 significant figures, 11. I don't have all these written right here. 3 significant figures, so 2.70 times 10 to the third moles of CO2. There you go. Let's see what this is worth. Okay, this whole thing is only worth 3 points. If you miss the significant figures, take off 1 point. Number 12. The decomposition of potassium chlorate occurs as follows. How many moles of oxygen are formed if 141 grams of the original reactant decompose? So we have 2 and we start with 141 grams of this. And we want to know how many moles of oxygen are formed. There we go. So there we have our given and our get to. We're going to start with our given. We have to go from here to moles, and then we can go across to this amount of moles. So we're going to go times line. This goes down here. Now we're trying to get to moles, so we can go across that mole tunnel or bridge. One of these, when you add this up, it ends up giving you 122.55. And if you're having trouble with that, if you look this up, it's 39.10, and this is 35.45, and then 3 times the 16, that's where you get the 122.55. Okay, once you've done that, you have 3 significant figures, so your answer has to be in 3 significant figures. Now we're going to go across the mole bridge. And we're going to moles of O2. This gets a 3, this gets a 2. In 3 significant figures, our answer has to be 1.73 moles of O2. This cancels. Now this one has 2 movements, so getting to this first answer was worth 3 points, and then you taking it to the second answer is worth 3 points. And finding the gram molecular weight is part of the first part. Okay, we are on 13. When sodium is put in water, it quickly reacts according to the following equation. If 4.52 moles of sodium react with excess water, how many grams of hydrogen are made? So we have 2 sodium, and that's what we're working with. How many grams of hydrogen? There we go. Okay, so we are started with 4.52 moles of sodium, and we want to know how many grams of hydrogen. So we go ahead and start over here with what we're given. We know we're going to have to go from moles to moles to get over here. So we're going to go moles of sodium, and we can go directly from moles to the moles of something else in a balanced chemical equation. This gets a 1, that gets a 2, so that's going to end up giving us in 3 significant figures, 2.26 moles of hydrogen, and then we can take that to grams very easily. Every 1 mole is 2.02. And so that's got 3 significant figures also. And so that answer is going to be 4.57 grams of H2. 3 significant figures. Now, once again, there's 2 movements there. And so he's got the first part as being 3 points, and then the second part as being 3 points. And if you didn't do the significant figures correctly, take off a point in each place that you messed up. I'll tell you what, this time just take off 1 point for the whole problem on the significant figures, but it's going to start costing more. So I just want you to be aware of that. Don't want it to be a surprise. All right, number 14. A chemist reacts 150 grams of hydrogen monochloride, it's actually hydrochloric acid, with excess magnesium oxide. If the following reaction occurs, how many grams of magnesium chloride are formed? So we're starting off with ... plus. We are starting off here. Yields manganese chloride. I'm sorry if I said magnesium. It's manganese chloride plus ... Okay, we have 150 grams of this in 4 significant figures, and we want to know how many grams of this are formed. And I've got the right, yes, stoichiometric coefficients, which is very important. Oh, and that's, no, I don't. That's very important. Glad I looked. Okay, now I've got the right stoichiometric coefficients. Everything else is going to be wrong if I mess that up, so you got to make sure you have those. Okay, so now we can start. Okay, so we start with where we have numbers. We know we're going to have to go from grams to moles, moles to moles, and back down to the grams. So I'm going to do that times grams HCl to moles HCl. And then I am going to go from moles to moles. So this goes here, and we're going to go across the mole bridge or the mole tunnel, manganese chloride there. And then this is going to go down here. And we're going to go to the grams of that. Okay, now we can put our numbers in. So for every 1 mole of this, we're going to add this up. It's going to be chlorine plus 1.01, and that is going to be 36.46. We got 4 moles of this to every 1 mole of this. And then 1 mole of this, we're going to add this up. That by itself is almost 70, and then the manganese, so it's going to be 125.84. Okay, we have 4 significant figures. I'm sitting there looking. I got 4 over there, 4 over there, 4 over there. So 4 significant figures in our answer. Make sure that everything cancels. It does. And so we are left with 129.5 grams of manganese chloride. Now, he's got this problem as being worth, I'm sure, 9 points. So he set it up piece by piece by piece. And if you did that, you can look in the book to figure out what your points would be if you found you messed up someplace in between. If you set this all up and you came up with a different answer, you need to put it in your calculator again and check your calculator and see if you just messed up the calculation. When you're in college, make sure that you always do all of your problems a couple times and make sure you get the same answer a few times, because you don't want to take a chance on just putting it in incorrectly and then getting the wrong answer on a college test. That'd be bad. That'd be bad. Okay. Let's see. That was number was that? That was number 14. Number 15. Suppose you have the following samples. Which has the fewest number of atoms? Well, to figure that out, we're going to have to go to moles, aren't we? To figure out how many atoms are in each of those. And so, let's do each of these. First, we have 24.31 grams of magnesium. We have 9.01 grams of beryllium. We have 5.10 grams of lithium. And we have 12.01 grams of carbon. Now, right away, I can tell you that, well, if you look at your periodic chart, that's a mole of magnesium. It's right there. That's a mole of magnesium. And beryllium, that's a mole of beryllium. And lithium, that's less than a mole of lithium. And carbon, that's 1 mole of carbon. So, if the question was, suppose you have the following example, which sample has the fewest number of atoms? These are each a mole. This is less than a mole, so this one has the least amount of atoms, and therefore C would be the one with the least amount of atoms. There was no hardcore calculations this time. You just had to see that the others were moles, and then that one's less than a mole. Okay. 16. Turpentine can react with chlorine gas to make carbon and hydrogen monochloride. Suppose a chemist runs this reaction and makes 569 grams of carbon. How many grams of turpentine are consumed? So we have C10, H16, and we're actually looking for how many grams of this were consumed. And we are, okay, so we go plus, dot, 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 and the other thing that's given to us is carbon, which is 10 carbon. Okay, that is a 1, that has a 10, and we are given 569 grams of carbon. There we go. How many grams of turpentine are consumed? So that is our given and our get to. All right, so we start with our given. 5, 6, 9. Remember, we're going to go grams to moles, moles to moles, moles to grams. That's what we're going to do. And I'm sure that he's giving you, he's giving you 3 points for each step. So first we go grams of carbon, and we're going to go to moles of carbon. For every 1 mole, there's 12.01 grams of carbon. And then that takes us here. So now we're going to go across the mole tunnel or bridge. And we're going to go to the turpentine. This gets a 10. That gets a 1. And now we're going to go the third step from the moles to the grams. And 1 mole of this, you're going to go 10 times 12.01 for carbon plus 16 times 1.01 for hydrogen. It's going to give you 136.26. We have 3 significant figures to start with, so our answer has to be in 3 significant figures. I can talk. And so our answer is going to be 646 grams of turpentine. Each step is worth 3 points, so it's 9 points overall. And if your significant figures are off, take off a point. You did it. You finished test 7. This was an important one. If you have a real problem with this, I would really suggest you go back and study the chapter again and do the test again, because this is so very important to everything we're going to be doing. It's the heart of chemistry is stoichiometry. So please have your parent go ahead and put their initials on the top of your test and bring it with you to your next class. Follow your syllabus. I'll see you next week.